Hello, everyone. This is one of the most important sessions where we discuss different ways of calculating the cross product of two vectors. Okay, I'm going to explain four methods of finding the cross product of two vectors, and you can pick and choose and learn any of these methods you feel like it. So we have two three-dimensional vectors, vector A, vector B, 2, -6, -3, 4, 3, -1, and we want to find the cross product of these two vectors, okay, in algebraic form. The first method is by multiplying horizontally. Now, how does that work? I'm going to explain it to you. You are going to write these vectors one after another. So 2, -6, -3, you're going to rewrite this to -6, -3, and then the second vector you go 4, 3, -1, 4, 3, -1. Okay, so you write these two vectors twice, one after another. Okay, and then you create a box in the middle like this. So basically you are eliminating the first column and the last column. Okay, and then you start to do a whole bunch of crisscrossings in the middle. So -6 times -1, and then 3 times -3, crisscrossing here and crisscrossing there. Okay, so like this. So we're going to do -6 times -1, all right, and minus 3 times -3. So this times that minus this times this. Again, this times this minus that times that. And this times this minus that times that. Okay, so I'll show the work for the cross product. We end up with -6 times -1 minus 3 times -3. That's the first component. -3 times 4 minus 2 times -1. That's the second component. And then 2 times 3 minus 4 times -6 is the third component. So you see how convenient it is and how fast it is. So the answer would be here 6, and that is positive 9. They add up to 15. Okay, 15. And this is -12 plus 2, which is -10. And then we have 6 plus 24, which is 30. So there you go. The answer is 15, -10, and 30. That's the cross product of the two vectors A and B. That's one way of doing it. Another way is just to multiply vertically instead of horizontally. So we sort of do the same thing, except that we write them vertically. So we go 2, -6, -3, 2, -6, -3, top to bottom, and then 4, 3, -1, 4, 3, -1, and we sort of draw the box again this time around the middle part, and we basically omit the first and last row, and we start doing the same crisscrossings here. So this times that, this times this. So we end up -6 times -1, okay, and then minus 3 times -3, okay. That would be the first component. Or -3 times 4 minus 2 times -1, okay. That would be the second component. And then 2 times 3 minus 4 times -6, that would be the third one. So again, we end up with the same answer of 15, -10, and 30. Except that here we did it horizontally, or there we did it vertically. Whichever one you prefer, you can do it that way, okay? So don't forget, you write the two vectors, one beside another, twice, one underneath the other, and then you draw a box around the middle part. The first row and last row you just omit, and then you start doing the crisscrossings. So that's a second way of finding the cross product of two vectors. A third way is by using so-called magic circle, which is basically using the unit vectors along x, y, z axis. So imagine if you have I hat and j hat and k hat. Okay, so if we consider a circle like this, okay, All right. What is I hat cross j hat? You know that I, j, k are all mutually perpendicular vectors. So sine of theta, which is sine of 90 degrees, would be 1. So when you want to find I cross or I hat cross j hat, it will be magnitude of I, which is 1, times magnitude of j, which is 1, times sine of the angle, which is 90 degrees, which is 1 again. So you see that it's going to be 1 in terms of its magnitude. But what is the direction of this vector that is found by finding the cross product of I and j? Well, if you remember the right-hand rule, I is along the x-axis and j is along the y-axis. So I cross j would be actually k. And we know that its magnitude is equal to 1. So I cross j would be k, right? K hat. But if it's the other way, like j cross I, it would be negative k hat. So basically, using this magic circle, we can quickly find this out. I cross j is equal to k, j cross k is equal to I, k cross I is equal to j, and the same cycle keeps repeating. Now, if you do not rotate clockwise, if you go counterclockwise, it will be negative. For example, j hat cross I hat, rotating counterclockwise, it will be negative k hat. Or I hat cross k hat would be negative j hat, and k hat cross j hat would be negative I hat. So depending on which direction you rotate, you can find all those products easily. Now, why did I say that? Because these vectors, A and B, can easily be written in terms of ij hat, ijk. So 2i hat minus 6j hat minus 3k hat. This is the first vector. Cross the second one, 4i hat plus 3j hat minus 1k hat. See, I wrote the vectors in terms of the unit vectors along the xyz axis. And now I just do the distributive property. So I have 2i hat cross 4i hat, basically. Okay, and then I have 2i hat times 3j hat. Okay, and then we have 2i hat times negative k hat. Okay, and then I multiply 2i hat by everything, and now I add negative 6j hat cross 4i hat. Okay, that's the next one. And then next one will be negative 6j hat cross 3j hat. And then last one, 6j hat cross negative k hat. Okay, so I multiply 2i hat by everything, negative 6j hat by everything, and now I multiply negative 3k hat by everything. So that will be negative, that will be 4. So this is 4i hat. Okay, negative 3k cross 4i hat. And next one would be negative 3k hat cross 3j hat. And then the last one would be negative 3k hat cross negative k hat. Okay, so I just do the sort of FOIL, you can say, from algebra. And now we just have to see what these outcomes are. We know that I cross I is 0. That's a fact, because I cross I, or j cross j, or k cross k, the two vectors are parallel. I hat vector is parallel with itself, making a 0-degree angle. So the product of I cross I would be the 0 vector, basically. Same thing with j cross j, k cross k. So all those terms that they have I cross I, or j cross j, or k cross k, all of these will be 0, they will be gone. And we know the associated property. So 2i hat times 4i hat is the same as 8 times I cross I, but I cross I is 0, and 8 times 0 is going to be 0. So basically, this term is going to be gone, and this will be gone, that's 0, and even this term will be gone, that's 0. So we are left with 1, 2, 3, 4, 5, 6 products. Now I cross J using the magic circle would be K. So the answer is 2 times 3, which is 6 K hat, all right? I cross negative K, so that's basically negative 2 times I cross K. So I cross K, you see that I have to rotate counterclockwise. I cross K is negative J, so that would be negative J hat, okay? Then I have negative 6 times 4, which is negative 24, but J cross I hat. J cross I hat would be negative K hat, okay? We're rotating counterclockwise. Then I have this one, which is going to be 6 J cross K is I, so 6 I hat. And then I have this one, negative 12 K cross I would be J hat. And this one is negative 9, and it's K cross J. K cross J would be negative I. So negative I, there you go. So now I just have to see what I have here. I have 6K, and that is positive 24K. So that would be 30K hat. Then I have 2 J hat, negative 12 J hat, that's negative 10 J hat. And then I have 6I, and that is negative times negative, positive 9I. So that would be 15I. Okay, 15I. So this is the final answer I get. I can write in the correct order. 15I hat minus 10J hat plus 30K hat, which in algebraic form, it will be nothing but 15, negative 10, and 30, of course. So this is the same answer we got from the other shortcut methods. So this is another way you can find the cross product of two vectors. Write them in terms of unit vectors along the XYZ axis, that is in terms of I hat, J hat, K hat, and just start distributing. But remember what I hat cross J hat is, that is K hat, and also backwards. And that's another way. And the fourth method of finding the cross product of two vectors is simply by using the formula. Some people might prefer to memorize the formula. They're good in memorization or whatever, and they can just plug in numbers and find the answer in one shot. So we're not saying that is not right. So here, A cross B would be negative 6 times negative 1 minus negative 3 times 3. I'm just plugging in the numbers, A1, A2, A3, 2, negative 6, negative 3, right there, and B1, B2, B3 are 4, 3, negative 1. So that will be the first, and then I'm going to plug in here negative 3 times 4, and then I'm going to plug it in for the last one. Okay, and that will be the answer. So that's 6 plus 9, which is 15, and that's negative 10, and that will be 24, and 6 is 30. So you see that we are getting exactly the same answer no matter what method we use. Okay, so I showed you 4 different ways of finding the cross product of two vectors, and you can choose any of these methods if you like it. And as you see, the answer is the same answer. So once, twice, 3 times, and 4 times, I got exactly the same answer. Okay. I think you're going to go by the method that you practice more often. You become fluent in that method. So if you use this first method and you use it several times, you get used to it, and you always use this one, and you're not going to worry about the others. Or if you like this method and you always use this, you become fluent in this, then you're not going to care about the other methods. You always use that method. So whichever method you feel like it, you can use it. My job was to show you 4 different ways of doing it. I got the same answer 4 different times. I took my time explaining each method. The rest is up to you to see which one you like, which one you want to use in future. Okay, so keep practicing it. Thank you.